So today we're going to talk about sex-linked pedigrees. So do you remember sex-linked Punnett squares where we had the X's and Y's? Well, we had talked about that these sex-linked traits are found on the sex chromosomes. Do you remember which chromosome, the X or the Y, are these traits mostly found on? They're found on the X because it's a lot larger. It doesn't mean there aren't any on the Y, but most of them we're going to be talking about are on the X chromosome. And we talked about 4 different diseases. We talked about colorblindness, muscular dystrophy, male pattern baldness, and hemophilia. So we've also done pedigrees, and today we're going to look at pedigrees that show sex-linked traits. You'll notice this might be an example of a sex-linked pedigree, and it looks the same, excuse me, as a normal pedigree. So we can't tell how something is inherited just by looking at a pedigree normally. There's some clues that can help us figure it out, but there's not like a different color or notation for sex-linked pedigrees compared to regular ones. So as a reminder, what shape represents a male? So males are squares, and then males have XY. So one of the things we have to remember is if we think that this is a sex-linked pedigree, we need to include those X's and Y's. What you're going to be doing is you're going to be given a pedigree and you're going to have to kind of figure out what you think the inheritance pattern is. Do you think it's dominant? Do you think it's recessive? Or do you think it's sex-linked? And remember, one of the things we looked at is that with sex-linked, it usually affects the males a lot more. So notice in this pedigree, we see a lot, the only people who are affected are males. That can be one clue that it might be sex-linked. So for our pedigrees, when we solve these pedigrees, and this is not just sex-linked, but this is for all of them. Remember, we have to figure out if it's dominant or recessive. As a reminder, if we see 2 parents that are unaffected, they have an affected child, that means the trait is recessive. So in this pedigree, is this going to be dominant or recessive? Here I see 2 parents that are unaffected that have affected kids. So this would be recessive. And I'm going to give you a hint. Most of the time, when we're doing sex-linked, it's going to be recessive. So if you see a pedigree that's recessive, you'll know it's either regular recessive or sex-linked recessive. We don't have any sex-linked dominant ones. All right, so then we're going to give all the females, if we think it's sex-linked, we're going to give all the females XX and all the males XY, okay? So we already said it's recessive, but we have to add the X's and Y's because we think because there are more boys affected than girls that it's sex-linked. And we're going to try and see if it works. So all the females get X's, males get XY. I like to put this little dash here next to the X's to remind myself that there needs to be a letter that goes in there. A lot of times kids forget to put some of those letters in. So then same problems, we're going to fill in the letters on the individuals we can guarantee. They go on the X chromosome. And if we can't figure it out, we're going to use a question mark. So let's take a look here. First thing I notice is that these guys are shaded. They have to have only lowercase letters. So I'm going to fill in these guys with lowercase letters. And I'm just going to use an A. You can use whatever letter you want. The unshaded ones we know have to be normal. So they have to have at least 1 capital letter. So I'm going to fill in all of them with 1 capital letter. Now for my little blanks here, you can see I still have some of these that I don't know because we don't know if they're big A, or big A, little a. So these are the ones I have left. So now what we can do is trace up or down to figure out what those genotypes might be. I usually like to try to pick a recessive person or someone with a disease to trace up or down because usually we can figure some stuff out then. So in this example, we know that this person is X with a little a and Y. Where did the Y have to come from? Well, the Y had to come from here, which means the little a had to come from this parent. So this parent up here has to be X with a big A, X with a little a. We can also take a look at these guys and look at their parents. So they have a big A. Where did the big A have to come from? Oh, the big A had to come from this person because they're the only one that has a big A, which means the little a has to come from this person. And so if this kid has a big A and a little a, then all of these have to have that same thing because the big A come from this parent and the little a from that parent. So you just fill them in. So again, our steps, figure out if it's dominant or recessive. If we think it's sex-linked because there are more females affected, or sorry, more males affected than females, we can go ahead and determine, okay, it might be sex-linked, and then we can fill in with X's and Y's.